Over the last 4 to 5 months, I've been designing and building my new 3D printer from the ground up. My goal with this build was to use the tools and machines that I have on hand, and with my old printer being in a non-repairable state, I machined almost all parts on my DIY CNC. This took quite a bit of trial and error, and I ended up with a whole box of bad parts, but I learned a lot, especially about machining on my DIY CNC and designing for one-off builds. In this video I want to finish the printer and hopefully get to my first test prints. So this is the current state of the build. Over the last couple of videos you could see that I first focused on the CoreXY stage and then afterwards my custom DIY extruder package here in the center. I now want to build up the entire printer, so make it three-dimensional to be able to mount the Z-axis components. Using the machine brackets I can assemble the printer according to the CAD design. If you want to check out the 3D files, I will add them to the GitHub repository below. So with this I now have the base assembly or structure of the printer. The Z-axis will be in this sort of area, and I've left a bit of space down here for the electronics and the power supply. Right now, without any of the Z-axis components, there's a bit of wobble in the structure, and I have to see if when adding the Z-axis components this goes away, or I will need to add some strengthening pieces to make it a bit stiffer in general. But next is at first the machining of the Z-axis components. So these are the parts for the Z-axis movement assembly. I decided to make it out of multiple parts, especially where the lead screw connects to the linear rail, and then also later the heated bed, to make it out of multiple parts, to be a bit more flexible if I have to make any changes later on. I have a sort of test setup right here to also see how long the lead screw will be. I have these three here that I will then cut according to length once I finish playing around with it and knowing that it needs to be exactly this long. Being able to make adjustments is also the reason why I'm using aluminum extrusion in this build. This allows me to change the dimensions without having to remachine a lot of parts, and this is also somewhat the goal of this build, to be able to change the X and Y travel, for example, without having to machine all the components, maybe just 2 or 3 connecting pieces that need to accompany that. So with the components for the Z-axis movement, almost all the structural components are in, just the assembly for the heated bed is missing. I'm currently aiming for a 220 by 220 millimeter build volume, which isn't the largest, but I think it will be fine for now, and as said, I'm trying to keep it adjustable so I can increase it later on without too much modification. I also try to keep the scope creep to a minimum, or better said, as low as possible, and I aimed for 220 by 220 beginning, so I'm just sticking with it. So this is the structure that the heated bed will sit on. I decided to machine it out of 4 individual pieces and then screw them together to form quite a sturdy base. I decided on 4 pieces to save some material, weight, but also cost, and this is sort of the, I would say, almost the largest pieces that I can machine on my CNC. It's 280 millimeters finished final dimension, and my machine isn't currently set up for handling those kind of parts. I had to get quite creative with the work holding, and moving farther away from the vice D and mill didn't sound too happy anymore, but I think I got away with it. On the structure, the heated bed, which is a sort of PCB with an aluminum top plate, which will sit on it like so once I mount it to the machine. So this is the part where the 3D CAD design and reality sort of meet, because these screw holes should align. They don't, and this is to be expected. They don't miss completely, they do overlap a bit, so that means that I can probably adjust the Z-axis screws a bit to make them fit. So the base now fits. I did have to move things around a bit and also drill out the holes. This is why I'm now using washers and these 3 bolts. I'm using these springs from my old printer, but I will have to get longer bolts as the stack up is a bit longer. But using these thumb screws, it makes a preliminary bed level quite easy. So I think the design turned out great and everything fits surprisingly well for this being a 1 out of 1 machine. Before going into the electronics, there are 2 design decisions that I want to mention. First is the choice of using 3 Z-axis motors. In the beginning I thought that I will use 4 for aesthetic and symmetry reasons, but ended up with a triangle setup. This should be a good balance between stability and complexity. I am intending to drive each motor independently and then using the automatic Z tilt adjustment in Klipper to level the bed completely. And the second one is using lead screws instead of belts. There are pros and cons to both sides. There is speed and reduced wear on the one side and sort of simplicity and less Z drift on the other side. I decided to go with lead screws because I already had them lying around, and if I see that the speed isn't enough for me, I may change to belts in the future. I'm using a dense foam board as the base for the electronics, so the power supply as well as the motherboard itself. For the motherboard, I'm using the Big Tree Track Manta V2 and the CB2 Compute module. The stepper motor drivers are all TMC2209 and will be controlled via UART using the motherboard. Everything is powered by the 24-volt power supply sitting right next to the motherboard. I will start by plugging in the stepper motors, and right now I'm leaving all the cables a lot longer on purpose, and I will shorten them and route them once the printer is up and running and functioning. Just because it's way easier to shorten cable than it's to lengthen one. As the nozzle and thermocouple of my extruder comes with a mini Molex connector, I decided to make all the connections at the extruder to be disconnectable via the mini Molex. It took a bit of time to find these connectors, but in the end I think it makes for a really neat setup. As part of the hot end extruder assembly, the extruder stepper driver, the hot end itself, the thermocouple, as well as the cooling fan gets connected. With some final touches, like the magnetic print surface on the heated bed, the printer comes together. So with this right now, everything is a bit of a mess. I have left the heated bed off the printer for the first power up to be able to see a bit better into the wiring mess that I just made. Something that is more temporary than it should be are the end stops. They should work, but this is the first thing that I want to fix once the printer is up and running. For me, the first power up is always really nerve-wracking. I will plug it in and just hope that no magic smoke will escape. Otherwise, that will be expensive. No smoke. Power light, boot light. I also don't smell anything. So this is the first printer that I'm building with running the Klipper software and also the type of mainboard. I did a bit of testing to get the CoreXY stage working, but now I'm at the stage of the build where I have to actually configure the software and the sort of hardware motherboard side that it can run my custom 3D printer. My goal here is to get a sort of minimalistic version running first and then add on features later on. For this I started with the drivers, the end stops, here mostly working with the BTT pin layout and a Warren configuration as an example. A really nice upgrade from this printer compared to my old one are the TMC 2209 drivers. Being able to set things like maximum current and holding current in software is so much easier. Next then is the probe setup for the inductive probe that I'm using, and here I was able to get quite a good repeatability. Afterwards I can focus on the bed leveling. Here I started with the manual thumb screws and then used the automatic Z tilt adjustment to get within 0.2 millimeters. I believe there's still some room for improvements here, but it's good enough for now. Almost the last thing is PID tuning, and this for the extruder and the heated bed. Here I was able to avoid disaster quite close by sort of double and triple checking everything. Just before I wanted to turn on the heated bed for the first time, I checked its resistance and the datasheet again and then noticed that it's a 12 volt board. So if I would have run it with the 24 volts, I would have for sure fried my board. So right now my long-term temporary solution is just to run a secondary 12 volt power supply that is only there for the heated bed. Even this is quite close, as the heated bed and the power supply are rated for 10 amps max, so I limited the bed power to around 80%. As I can now heat up the system, the very last thing to check is the gears of the extruder. I'm doing this by marking known distances on the filament and then extruding a known distance and comparing it afterwards. And with this, the configuration should be close enough or good enough so I can actually start a first test print. So for this test, I'm more looking for nothing to catch fire and or run into itself than for a perfect 3D print. So I will just keep an eye on anything that moves unexpectedly and or smells. So, okay, I wouldn't call this a good print or a good like print result, but a great result because nothing broke and or got too hot or smelled funny. Also, this is without any slicer tuning and without a parts cooling fan. I haven't added that till now. I think I didn't scratch the build plate, which is great, like for a first test run. Also, which is sort of complaining on a really high level, right now the power supply is the most noisy item of the entire printer. So I will have to get a new and quieter power supply because yeah, if the printer is that silent, I just don't want to listen to the power supply all the time. So over the next couple of days, I chipped away at it, tuning things like the Z offset and the extrusion and slicer settings, and this is where the footage you just saw came from. I was also testing different speeds. Here some pieces are ranging from like 30 millimeters per second up to 80 millimeters per second. And yeah, this is the reason why some pieces are more beautiful than others. Some do have a bit of under extrusion. Some messed up completely. But it's getting to a point where I can start reliably a print and I get a functional part out of it. And I think with a bit more tuning, it will be a great setup. Now I also spend a bit more time cleaning up the wiring to make the printer a bit more presentable. At least as far as I can go now, as I'm still waiting on a replacement heated bed. But the printer is running smooth and projects like these are never really finished except when you call them finished once you're starting Gold Summit. And they are for me. So I will leave it at that and I will see you in the next one.